Alright, so this is simple linear regression. So simple linear regression attempts to summarize the relationship between two quantitative continuous variables in a straight line. That is, we're looking sort of for a straight line summary. Okay, so let's kick off with an example. Suppose that you want to estimate, say, a fair price for a used car. And we've got some data on 10 automobiles that have recently sold. Here are their ages rounded to the nearest year and prices in $100 bills. Okay. Here we might say that age is the independent or predictor variable, or sometimes called the explanatory variable. It sort of explains the variation or the change in price or something like that. Or maybe we can use age to try to predict the price. Okay, price is our dependent or response variable or outcome variable. Okay, we'll use all 6 of these terms from time to time. Obviously, there probably exist other variables, that would help determine the price, like mileage, make, model, etc. But let's just keep it simple for now and focus on age and price. So I have opened a session of R here. Hopefully, you have gotten R installed successfully on your machine. You can just Google the letter R and you'll find it right away, and you should be able to install that on your PC or your Mac. I will tell you right now that I'm using a PC. I'm using the PC version of R. Some of the commands for the PC version and the Mac version are a little different. Just be aware of that. You can always find the answers you need on the web. Also, some of you may be wanting to use RStudio, and that's perfectly fine. I'm just going to keep it simple and use just the straight R interface, just the command line interface like this. Okay, so let's begin by entering the data into R. Okay, so here's what I'm going to do. I'm going to be lazy about this. I'm just going to copy and paste what I can here from the PDF file. Control C that stuff. What I've got here then is I'm gonna take these numbers, these age numbers, and I'll just remember that they're in years. And in fact, if I want to denote that, I can comment that by using the percent symbol, and just do like that. Anything to the right of that percent symbol there will be a comment and not read in by R. What this is going to do, it's going to assign this. Well, of course, I've made a mistake already. Let's try this again. It's going to assign this array of numbers to this object that we're going to call age. Okay, I guess I've got my comment symbol there incorrect already. I think it's the pound sign. Okay, there we go. So in fact, indeed, if I type age now, you'll see that list of numbers in order. Okay. Now I also want to get price in there. Okay, I'll Control C that. Boop. Okay, got all my prices in there. You can see those prices. Okay. Now I want to create a data frame. A data frame is a type of data object. There are many different kinds of objects or classes of data type files that we'll use from time to time. You can use, you might create a matrix or a whole host of other things. It will be important to use the right type of data class for whatever operation that you're going to do. If you're going to do matrix operations, we'll see that you need to have your data in a matrix format. That's easy to do, but for now, just note that a lot of times we'll be making data frames. Data frames are real flexible. They can take all kinds of different data, quantitative, ordinal, categorical, all kinds of things. But what I'm going to do here is I want to, and be careful of this, by the way. Sometimes when you Control C, when you copy from the PDF file here, it doesn't copy exactly the way that you want. So what I'm going to do here is I'm going to create a data frame with these two arrays of numbers, okay, ages and prices. Age will be the first column and price will be the second column. And I'm going to assign that data frame to the name used underscore cars. Okay, so now if I type used cars, in fact, you'll see this data frame. Okay, and again, age is my independent variable and price is my dependent variable, or also my response variable. Okay, so you can probably, as you probably suspect, that the more age cars get on them, the lower in price they're going to be. So probably we're going to see a negative association here. Um, let's just kick off and do regression and also make a scatter plot of the variables there. So what I'm going to do is copy the that line there, and so this is the function called LM. It stands for linear model. We're going to make a linear model. We're going to use it to try to predict the price based on age. Okay, so this is like y variable tilde, meaning versus x. Okay, my x variable, and I'm calling the data. I'm retrieving these variables by first using the name of the data frame and then using the dollar sign there. I can then indicate what column. Okay, so I'm taking the price column is what I'm trying to I would like to predict, basically based on the age column, and then I'm running this linear model function, and I'm going to store the output in this in just a variable called regression. Okay, and if I type regression, you'll see what's in there. It tells me what I did, and the coefficients. It turns out the vertical intercept coefficient is 199.03. Of course, the units on that will be the same as the y units, $100 bills. And then this would be my slope. Okay, my slope coefficient, negative 12.5, and it's and your slope is going to always have, remember, it's going to have rise over run units. So your slope always has mixed units. It'll have, in this case, $100 bills per year. Okay, so I can also make a scatter plot. Okay, for that I'm going to copy all of this stuff and say plot used cars, the age variable, used cars, the price variable. This when you use the plot command, it's going to take, you want to put in your x variable first, comma, y variable, and then main. This is if you want to give your plot a title. So my main title will be price versus age data, and now maybe I want to jump to the next line. I'll press enter, and ours knows to be expecting some other stuff because we haven't closed up the quotes or the parenthesis there. So I'll add some more stuff. 410 used cars. And I'll also give it I'll label the x-axis with xlab, okay, and I'll also label the y-axis with this function ylab, and I'll put some other stuff in there, and you'll see what that does in a second. There's my plot. The PCH, I believe that gives me the size of the dots, and the call equals blue. Of course, that's color equals blue. Okay, just like the color blue. That's a pretty nice little plot. And sure enough, you can see that there's a negative trend, a negative association between these two variables. The human eye is pretty good at detecting that, and we've actually already seen what the regression command will do. It'll give us the slope and intercept of the best fitting line that runs through that data point pattern, and in fact I can drop that line onto my scatter plot by using this command called AB line. AB line means it's a line going through points A and B. It's going to use what's it'll use the intercept and the slope coefficient there, And this is the line weight, and this is the color of the line. Okay, put that stuff in there like so. There we go. Here's my regression line. Okay. So what do you think would happen if we made a scatter plot and a regression line for the standardized data? Okay, we talked about standardized values, or z-scores, not long ago. So let's standardize those variables and do the same procedure. First of all, let's introduce you to this command called attach. See, if I attach the data frame used underscore cars, then I don't have to type used underscore cars $age anymore. If I just type age, then it knows what I'm talking about. Okay, so let's standardize the ages, and I can do that by I'll take age. This sort of, you can think of it as a vector of ages minus a vector of mean ages. Okay, this is not a scalar right here. This is not just one number. It's actually an array that consists of all of 10 replications of the average age, and then number by number, it's going to divide by the standard deviation of all the ages. Okay, so this will actually get me, if you want to see what this is, it's an array of all the standardized ages. Okay, let's do the same thing with the prices. I'll standardize all the prices. And by the way, we are dealing with data here, and the SD function gets the sample standard deviation. Okay, standard STD price. Okay, yeah. Okay, so you can see all these numbers are clustered around 0, -1 point something, 0.316 something. Okay, just as we would expect for standardized data. And now I'm going to make a data frame of those standardized variables, and you can see that's STDUC for standardized used cars. Okay, so you can see that our first data point was actually about -1 standard deviations. It's about 1 standard deviation to the left of the average age, and then the price on that car was about 1 1/4 standard deviations above average. Okay, now I'm going to use this command Windows parenthesis. What this does is this will allow me to make multiple graphs. It'll allow R to it tells R to make a new window when we make a new graph. Otherwise, it'll write any new graphs over the same window here. But I kind of want to keep this because I like it. It's really pretty. I'm going to put this guy here. Now, if you are using a Mac, this is one command that'll be different. I forget what it is. I think the analogous Mac command might be quartz. You have to check that, but that's probably because, of course, Macs don't want to use a command like a command that says Windows. So you can see that, in fact, it's done what we said it would. It left this graph alone, but now we're poised to make a new graph. I want to attach this standardized data that I've got there in the so that I don't have to keep typing STDUC all the time. Now if I redo regression here, I want to make a linear model of standardized price versus standardized age. See, I don't have to include the name of the data frame. And now if I do plot, I can make a plot of the standardized age and price data there. Okay. And there we go. We can compare these two plots, put them side by side, and lo and behold, you know what? They look the same. Except for, this one has a red line and this one doesn't. I guess we could drop a regression line on there. We could do, you could check that out. Okay, now these two plots look the same. I think they look exactly the same, in fact, right? The only difference is the scaling on the sides. Okay, it's doing exactly what we said that z-scores should be doing, right? All it's doing is it's shifting and stretching these data point patterns so that, you know, if this is our original data point pattern, it just rescales everything along the horizontal and the vertical axis so that the center is now at 0, 0. See, this is 0, 0. 0 age, 0 standardized price, 0 standardized age, excuse me, and 0 standardized price. Okay, so it turns out, in fact, one of the properties of the regression line that runs through the standardized data is that it runs exactly through the point 0, 0. Similarly, the regression line for the original data set will run exactly through the so-called sort of center of mass of the random point cluster. Okay. Alrighty, so this brings us to our next topic, and I'll wrap things up here in just a second. But it turns out there are many different lines that you could possibly draw through this random point cluster, right? How do you pick the so-called best one? Okay, how do you pick the so-called best one? Well, that's what the next section and of notes will be about.